Hello, everyone. How's it going? Today, I will be discussing my project, which was to record the average temperature in a room for 30 days. I did this at the same time every day for 30 days, and what I was hoping for was to use this data to tell me how much more each degree in temperature is costing me on my energy bill. Well, according to the Florida Public Service Commission, temperatures below 78 degrees can increase between 8 to 12% for every degree. As you'll see later on in the project, I use 10%. It's just a nice number in the middle. If you look here in the picture, you can see right above the green light, there's a white button, which is the boot cell button. And once I click that, connect that micro processor or microcontroller, excuse me, connect that microcontroller to my computer and have the appropriate firmware and packages for my Tony IDE, I was able to get temperature read and even create a user interface. Now, at the beginning of my project, I really just wanted to get the average temperature, but as the progress the project progressed, I realized that, hey, how about I make that data a little bit useful by analyzing that data and seeing how much it's costing me based on the difference in degrees from 78 degrees. Although I didn't have a lot of technical issues, at some point I did have some slight issues with the HTML and creating a user interface, but that was about it. I would say the biggest success in this project was making that data useful and seeing how much it's costing me based on the degree that is below 78. If I could do this project over again, I would probably invest more time on the UI just to make it nicer. Right now, it does everything I need it to do. It works fine, but maybe adds a couple of bells and whistles. And the languages that I use was one, I use Python, and I use the Tony IDE and some packages. And you'll see those packages later on as I go over them. I did use Jupyter Notebooks, and the reason why I use Jupyter Notebooks, even though I could have done everything in Tony, was because Jupyter Notebooks lets me have cells and I can execute different portions of that entire code based on the cell. So if I have a function from cell number one, instead of executing that whole program, it'll just execute that function, which is nice. It's more clear and easier to work with, especially when I'm having a presentation. Well, let's get started. Now, the Raspberry Pi Pico W is a new version of Raspberry Pi that enables Wi Fi capabilities. Since I can connect it to my Wi Fi network, I can access the app features through any computer or mobile device on my network, such as my iPhone or iPad by going to the IP address. You can see here at the top, I have imported the network package, socket package, sleep, Pico temp sensor, Pico LED, and machine. Also, you see that I have the SSID and password for my network. Well, if you've ever connected to a Wi-Fi network, you'll notice it doesn't happen automatically. My device needs to request to the Wi-Fi router to connect. And when the router responds, they will perform what is called a handshake to establish a connection. In order for me to do this in Python, I had to set up a loop that would keep sending a request every second until the connection or handshake was performed. And that is why you see here that I have the SSID and password to make that connection. Next, you'll see that I opened a socket. Now, a socket is a way for the server to listen to a client that wants to connect to it. I had to have provided my IP address and a port number. The port numbers are used by the computer to identify where a request should be sent. Although I use port 8080, if this was something that was publicly accessible, it'd probably be better to use a secure port with SSL. But for a home environment, port 8080 is just fine. Next, you see that from line 31 to 47, I created a function that would have some standard HTML code, and in that HTML code I have temperature and state, and the temperature and state on line 43 has been passed through the function web page, and then I return that HTML to be served by my server. So you'll see here that I created a function that will start my web server using the connection object. The state and temperature variables have been set for my HTML data. And then you can see there I can have the state for the light to be on or off, as you saw in the previous image on the micro controller. In the next slide, you'll actually get to see the user interface with the state and temperature readings. As you can see, LED is on, have light and off button. Also, there's the temperature in Celsius and in Fahrenheit. By default, the Pico libraries and the microcontroller has the temperature in Celsius, so I did some little bit of add-ons to have it in Fahrenheit. All right, so in the next step, you'll see how I was able to use some Python libraries such as pandas to organize and get some very simple and easy statistics. NumPy array was useful to help me set up my array. And you can use NumPy to do all sorts of things such as sorting, indexing, slicing through different arrays. The Matplotlib library was useful for me to create graphs to help visualize that data. Now you can see on the second cell, I have an array with all the temperatures for that month. And then on line 6, I use the describe function so that way I can have a nice representation. You see that I have a count of 30. The mean temperature was 76 degrees with a standard deviation of 0.525226. The minimum temperature was 75 and the maximum temperature was 78 degrees. Here in the 7th cell, you can see in the graph that for the most part everything is consistent with a few spikes. Downward spike at 75 degrees and peak spike, upward spike at 77. That's actually the highest is 78, but there is another spike at 77 degrees. So the highest, again, of course, was 78, and the lowest was 75. Now, in the first cell in this slide, you'll see that I have some information. So I have a 2-ton AC, which is 2,000 watts. And the way to calculate the energy consumption would be to have the kilowatt hour, which is 2,000 divided by 1,000. And the average cost per kilowatt hour is 12.8 cents. So it costs 12.8 cents on average to run an AC for an hour. Here I have the 78 degrees daily cost, and I also have the 78 degrees monthly cost. We'll go here, and you'll see that okay. So in the next cell, I have a loop that's going to basically compare the temperature that day to 88 degrees. And for every degree difference from 78, it's going to compound that difference to 10%. And then we're going to multiply that by the result of multiplying the average cost per kilowatt hour by the kilowatt hour. So that would actually be 12 cents times the kilowatt per hour times the percent increase compounded by the difference from 78 degrees times 24 hours. As you can see here, my monthly AC operating cost is $223.29 compared to a constant 78 degree monthly cost of $184.32. So you can see here, I have $6.14 one day, and on most days, it's $7.43. At my house, we normally have the temperature at one setting. Every now and then we do change it, and if we do, we're not going to change it more than once, or else people are in big trouble. All right, so here's a nice graph here, and you'll see that the cost is roughly at about just under $7.50, and we saw previously that on most days it cost $7.43 to run the AC unit. And we have some upward spikes just under $8.25, and the lowest was just above $6.75. Well, now I hope that this was insightful, and this can give you an idea of how much it's going to cost you for every degree in temperature below 78 degrees. So, for each degree from 78, your bill or energy consumption is going to cost you 8 to 12% for every degree that you go down from 78. Thank you. Have a good one.